Okay, in this tutorial I'm going to describe how to generate a 3D model of your stool so that we can make this drawing your exploded axonometric. Okay, so the first thing I want to do is work from, start by using the plan drawing that I've generated of this of this design. So I would select my plan drawing, and actually I want to make sure I have my inside edges as well, or my inside rectangle as well. Type in copy, and I'm just going to kind of move this out of the way because later on when we do our drawings we won't want anything else in the way of this set of drawings. Okay, and then I'm also going to go ahead and turn my current layer to default. And I'm going to make my whole 3D model on that layer. And that's just going to make it a lot easier when I'm done and I want to actually make a drawing from the 3D model again. It's going to keep my line work a lot cleaner. Okay, so I can model this thing by going into perspective, and that will allow me to kind of look at the thing in 3D. But I actually prefer to use one of the Paraline viewports, or one of the top front right viewports. And if I hold Control Shift right click on the keyboard and drag my mouse around, I can actually orbit. And what's cool about that is I can see 3D things just like I would in the perspective viewport, but zooming in and out is a lot easier than it is in perspective. And you'll see that when you zoom in perspective, at some point you won't be able to go any further. It starts to get bothersome, or you'll get lost and stuff like that. Anyway, it's just a little bit easier to navigate in 3D when you're in a Paraline view. So in top view, I'm going to go over to the copied plan drawing that I have here. And the very first thing that I'm going to do is draw some squares at each of the corners. That'll represent the vertical members of the stool. I'm going to go over here to rectangle. I'm going to choose 3 point because we're drawing a rectangle that is at a 45-degree angle. Okay, and then I can actually just copy this one instead of drawing it 3 more times. Okay. And then I'm actually going to go ahead and delete all the rest of this stuff. It's just going to get in my way as I'm modeling. Okay, so step 1 will be to extrude these 4 edges. So I'll select those rectangles, type extrude CRV, or extrude curve, press enter, and you can see now it's gonna extrude them perpendicular to the plane on which they're drawn, which is perfect. So we need to set a distance, and we also want to make sure that we hit this option solid. So make sure that the solid option is set to yes. When we actually model the joints, we're going to use the Boolean tools. Now it doesn't matter yet what that means, but it is important that we have closed poly surfaces. So I'm going to type in the dimension of my stool, which is 18, and I'm going to hit enter. Now first of all, you can see that we're looking at a wireframe view, so I'm going to go up to the top left, right click, change it to shaded, just so I can see. And again, because I hit the option solid, I have little surfaces at the ends of my verticals. So they are closed poly surfaces. Okay, and then I would also want to go in here now and draw the horizontal members. Now I could do this a lot of different ways. I could do the same thing as I just did, draw a 3-point rectangle. If I were to snap to the vertical of my existing horizontal member and type 1.25 to set the distance, I could draw like a vertical rectangle and then extrude that. extrude it all the way to the outside edge. We want these members to go all the way through each other, because we'll need that in order to model the joints properly. And then I'll delete that original curve. We could also draw a rectangle at the whole length of the horizontal, and then extrude that to 1.25 inches. And of course, we could also just draw a solid. So we could use the option box, or the command box, the option 3.1, 2, 3, and then 1.25. Okay. And once you've made one of them, you can also just mirror them and copy them. Use the midpoints of your rectangles. Okay, so we're going to start from that. That's basically all the members of our stool. But we also need to use this stool, again, like we did with our plan, to represent the order of the joints. Or I'm sorry, use this drawing to represent the order of the joints. So I would go back and look at, okay, how are the joints drawn on my plan? So I want to start by drawing or making cuts in this member in order to represent how those pieces would meet. So first of all, you can see that this member goes over that member. So what I want to do is actually make a box. So I'm going to type or hit the command box. Again, I'm going to choose 3-point. And I want to go in here and find the intersection point. So when you snap to things in Rhino, you can see the little text box next to your cursor tells you what you're snapping to. In order for this modeling to work, we need to be really precise in what we're snapping to in order to make this like subtraction. So I want to make sure absolutely that I'm snapping to the intersection and not just the near. So you can even turn the near snap off if you want to make sure you're getting it. Then it'll say the next the end of that edge, so I'll just rotate. Again, I'm rotating by holding right click on the mouse. I'll snap to the next intersection. And then here I just need to snap to somewhere on that bottom edge. Okay, so we're basically drawing a box right at the intersection of those two members. But now we need to define the height, and rather than making it the full height, we're going to make it half of the height, which is 5/8. So 5 divided by 8, press enter. Actually, for some reason it drew it downward, so I can just hit move. And again, make sure you're snapping to the endpoints. The number one way that models get screwed up is snapping to the wrong points or not using ortho. Okay, so now if I reference my drawing again, you can see that this member is the one that goes through. So I'm going to use that box to make a subtraction from this horizontal member. So I'm going to type in the command Boolean Difference. Now all the Boolean operations do is they perform like solid subtractions, additions, or unions. So all the Boolean commands basically allow you to do things like this: to use one solid to subtract from another solid, to join with another solid, or intersect with another solid. So in Rhino, we can do that in 3D and in 2D. What's nice is that it'll make sure, if we're using solids to model with, that we'll be left with solids at the end. So it'll say select surfaces or polysurfaces to subtract from. That's the horizontal member. Press enter. Select surfaces or polysurfaces to subtract with. That's the little box. So I'm just going to drag. Again, if you don't know this, if you click and drag in Rhino to the right, anywhere to the right, you'll see that your selection window will form a solid line. And what that means is that anything that's inside of that line will get selected. If I click and drag to the left, I'll see a dashed line, which means that not just the things inside, but also the things I'm just touching with it. So like if I'm just barely touching that other member with this box, boom, it's going to get selected. And I don't want to select that line, right? So I can hold Control and click on it to deselect it. So I just want to click and drag to the right around my little box, just so I'm selecting that one object. Press Enter. Okay. And then when I go ahead and select this object, you can see that it has this cut. So like I was saying, because we're using solids and Boolean operations, it's already formed like a closed interior face where we made that subtraction. Okay. I'm actually then going to go ahead and delete this member just for right now. And if you remember from the drawing video, the goal with this element was to make every single part be, or to make this tool be constructed out of as few parts as possible. Now, if you look at the drawing on your assignment, you can see that it's possible to use this same element for all the horizontal members, or the same set of cuts for all the horizontal members. So before I get too far, I'm just going to do kind of the same thing as I did in my plan, and I'm going to subtract the lap joints at the ends where they join the uprights. So again, I'll reference where they were in my plan. I could draw a box, 3-point. I'll use the edges of the existing intersection between these two members. Intersect, end and midpoint. Okay. Then I'll choose the same member, type Boolean Difference, and I want to subtract those two little boxes that I just drew. I'll just click on them, try and click on the edges, press Enter. Okay. And now you can see the member that I've created is has this orientation of cuts on the ends, and then it has you know, the middle joint facing down. Now, the easiest way to ensure that all your parts are going to be the same is by only using the same parts. So what I'm actually going to do is make a copy of this. I'm going to rotate it 90 degrees, and then I'm going to rotate it along its length. So I'll type in the command rotate 3D, and this command allows you to draw a rotation axis rather than just a rotation point. And I can choose any axis I want as long as it's along the length of my member. So it'll say start of rotation axis. I can snap to an endpoint, and I'm just going to basically trace that edge of that member. Snap to the other endpoint. And then you can see that it's showing me, okay, I'm going to rotate around that line. So I could type in, I could either click somewhere and then move it, or I can just type in 180 to rotate it exactly 180. So this is the same exact geometry, just reoriented or realigned. Now I'll type in move and move it back over. You can see that joint will work right there because this element is flipped. And you know, because these two are the same part, we can use them to figure out where we need to cut our uprights in order to make them the right parts. Okay, and before I do that, I'm actually also going to go down to the bottom horizontal members and delete them. Delete that curve as well. Okay, then I can select my two horizontal, type copy. Inside of the copy command, I'll hit the option vertical, snap to the bottom of one of them, bottom corner of one of them, and then snap to the bottom of your upright. Okay. And then what I'll do is actually select all 4 of the horizontals and copy them. Just move them out to the side a little bit, doesn't matter where. So now I'm going to use these members to actually do my Boolean operations. I'll type in Boolean Difference. So I'm going to do these two. I'll select both of those vertical members that intersect with these horizontals. Press Enter, select those 2 horizontals, and there we go. That joint is done. Do the same on the other side, Boolean Difference. Select the uprights, press Enter. Select the horizontals, press Enter. And there we go. And now if we take our copied horizontals and move them back, they should perfectly align to our joints. Okay, so that's the kind of best way to model the frame of the wood stool. And the reason that we're doing this really is to generate one of the drawings that's on the list, the exploded axonometric drawing. Now this one is basically the same as like this, right? It's a drawing. An axonometric is like a drawing that's tilted in 3D, and on top of the the kind of 3D view, we also want to explode a couple of elements, because what we're going to really use this drawing for is showing like, okay, which part is which, where do they go, and kind of how do they all fit together. So what I want to do is actually take a couple of the members of the 3D model and explode them before I make the drawing. Excuse me. So I'm going to take these, well, first I want to actually choose my angle. So when you're going from a 3D model to a 2D drawing, you always want to choose a drawing angle and you want to save it. In order to save it, you type in named view. Now I already have the panel open, but in here, once I've chosen like a viewing angle or like a 3D angle to look at my model, I can actually save it. That way, anytime I make changes, I can easily go back to this view and make a new drawing from it. Now, to choose the view, I just want to kind of rotate my drawing or my model until I can see clearly each element. So like we want to try to avoid one element being in front of another element. We want to avoid things where like edges get covered up, like that edge right there is being covered up. So we just want to kind of make sure that we can really clearly see each part. Okay, so that looks pretty good. And then I'm going to go ahead and in my named views, I'll click on the save icon. Call this my exploded axon. Okay. There we go. And so now, no matter what I do in my model, if I want to go back to that view, I just go to my named views panel, double click on it, and I'm right back there. Now, before we make 2D, like I said, we need to actually explode the elements we want to look at. So, with the wood stool, there are really, if you've done the modeling and drawing right, there's really only 2 elements. All the uprights just have 2 cuts on the same side, and all the horizontal members have the same 2 cuts relative to the middle, the orientation of the middle cut. So what I'm going to do is I'm going to explode both of the top horizontal members, just so you can see clearly how all the joints are oriented, because we can't, in the current state, we can't look inside of this joint and really understand what's happening. I'm going to go ahead and explode both of those members just by typing copy and by typing vertical. And it's important that you're in your exploded view at this point, because when you go to start moving, you want to make sure that the copies of the members are also not blocking your view of the model. I'm just going to move it up till it's comfortably out of the way of the 3D. Press Enter. And then I'm also going to go ahead and just type in move to hit vertical. And also I just want to make sure I'm not in the way of my original, or in the way of that member. I can move it a little further. Okay. So those 2 members have been exploded, and then I also want to explode one of the horizontals, or I'm sorry, one of the vertical. I'll type in copy. And for this one, I can actually just snap to the edges. I want to explode it kind of in line with this plane of the stool. So I'm going to choose one corner, snap to the other corner, and then I'll use this tab trick again. So if I just hit tab on the keyboard, it'll lock me into moving it in that direction. Now I could double click on exploded just to make sure it's not going to intersect with anything. Okay, and then click somewhere out there. Okay, so now we have a 3D model of our stool. We have all the elements we need to show kind of exploded off so that we can clearly see them. We need to go ahead and make a drawing. So I'm going to make sure I'm in the right view angle. I can zoom in and out, but my angle won't change, right? So I could actually resave, or I could save over that named view. And then I'm going to choose all of the elements to select my whole model, basically. So I don't need those lines at the bottom, but I want to select my whole model, the 3D stuff, and type in make 2D. Now make 2D is going to open a little dialog box. There's a few things I want you to pay attention to that might be different in yours. One is you want to make sure you have maintain source layers turned on. In this case, it doesn't matter too much because everything we have is on one layer. But normally when you have a complex 3D model, this is going to save you a bunch of time by keeping all the objects on different layers separate, so you can much faster line weight your drawings. I also want to make sure this option scene silhouette is turned on, and I'll show you why in a second. So once you have the options set up correctly, just click OK. Now, make 2Ds will always show up in top view, and they will always show up near the origin of your file. Now, because I just ran the command, it's automatically selected my make 2D line work. And you can see that because they're at the origin, they're actually on top of some other drawings. So before I do anything else, I want to go to top view. I'll type in top, and I want to move those out of the way so that I don't have the trouble of two sets of lines overlapping. Okay, and then if I go to my layers panel, you can see I have a new couple of layers in here. So I have one called scene silhouette curves, and I have one called curves. Now, because I made my 3D model on the layer default, that's what these layers are called. Normally, if you had a bunch of layers in your 3D model, you would have a bunch of layers here. But just to illustrate what scene silhouettes has done, if I right-click on the default layer, select objects, you can see that Rhino has automatically figured out which lines are kind of touching the air, which are the outlines of the drawing, and put them on a separate layer for me. So right away, I have a much easier time line weighting my drawing. So I will select those lines, go to the layer heavy, right-click, change object layer. Okay. And if I were to unpreview that, you would see that I actually have duplicate lines everywhere that I have a silhouette line. And that doesn't really matter, because I can also go down here and right-click and select these lines. And so these lines are going to be, just the regular lines that show how the geometry works. I'm going to right-click on medium and go change object layer. But, when we're done with this drawing and we print, even though there's two lines there, obviously the thicker line is just going to be the one that shows up. So we don't need to worry about having duplicate lines. Now, before we're completely done with this drawing, we got to add a little bit more detail to it. So I'm going to go under the light layer, and I want to go in here, I'll unlock medium. And everywhere that there's a line that separates a joint, or that makes a joint, we want to actually make those lines, or put those lines on the light layer. So I'm just going to go in here and select some of these lines, So anytime we have a seam that's like on a face, so this is like a continuous face, even though it's formed of two parts, and that's a seam between those two parts. So we really want to represent that as a lighter line weight, because we're not looking at the difference between two elements in 3D. We're just looking at a seam on a single plane. So I'll select all the lines that form my joints, and right click on the layer light and go change object layer. Okay, and then finally I'm going to use my go down to my layer dash, set that as current, and draw some lines from the outside corners, whoops, to where my exploded elements are. And that will just make it easier to kind of see which element came from where, and so on. Okay, so just 2 dash lines for each member. All right, and what I also want to do in this tutorial is begin to show you how to set up your layouts. So at the moment we have, maybe we have our exploded axon, our plan, our section, and our elevation. We'll do another video that will talk about how to make the cut sheet and the connection details. But I'm going to talk a little bit about how to compose your drawing right now. So we're going to use the same way, the same tool that we did in project 1. I'm going to go down here and make a new layout. So click on the little plus in your viewport tabs, click new layout. And here we got to make sure we're in inches by default. If we're not, we can change that by typing in units. Go to layout, make sure you're in inches. Okay, and then we also want to make sure our page size is correct here. So again, if we look at the assignment sheet, 11 by 17 is the page size. So make sure you're 11 by 17 and make sure you're in landscape. Click OK. Now you can see a new page has been added down here, or a new viewport has been added. And on this page, like I said in the last tutorial, this is like a little window into your model. So we can look at our drawings and we can kind of lay them out individually or together, and form a composition on the page using these windows, these detail windows. Now, what I want to do first is I'm going to change my detail view to a different layer. So I'll select that detail window, right click on default, go to change object layer. Now those lines shouldn't print, so you don't need to worry about where those lines or the edges are. We just want to make sure we can see where our model is, see as much of our drawing as we need to see. But the other thing that we'll use this detail view for is to set the scale of our model, of how we're looking at our drawing. Now, if I select the detail view, go to properties, and then go to the detail button, I will see in here an option to scale my detail window. Now, on the assignment sheet, it's going to dictate for each drawing there's a certain scale you want to use. So my plan, section, elevation, for example, are all 3 inches equals a foot, which means all I do is over here type in 3 inches equals 12 inches, or 1 foot. Okay, now you can see we've zoomed in more. We can see our drawings more closely, but they're still not really lined up with where we want to see them. In order to move what part of our model we're looking at in our detail window, we just double click in there. I'm automatically in top view, so I can just pan, right click to pan, and move over to where I can see my drawing clearly. Right click again. Now I can also select my detail window and drag it out so I can see as much as I need to. And the real reason that I want to show you this part before we get too far is number one, so that you can kind of lay out your drawings effectively. And number two, you can line weight them effectively. The first part of that is you'll have to go to D2L. So go to our D2L site, go to Contents, and go to Resources. And under Resources, there's a 3DM file called Shop Drawing Title Block. And if you download that file, you'll be able to go ahead and drag that into your Rhino model. So just click and drag it in. Make sure you're on your layout when you do it. And then it'll ask you, open, insert, import. We want to click import. Okay. And what that has done is it's added a title block. So title block is, something that we use to kind of identify what the drawings are, what the document is showing, organize how the pages are sequenced in the document, and just kind of give some general information of what the document is. So you can see right away our drawings are kind of intersecting with our title block, and we're going to have this title block on every page. So we want to kind of move stuff around a little bit just so we can kind of stay clear of the title block. If we go back to top view, I can move these guys over a little bit, save some space that way. I'm just holding shift. I still want to keep them kind of evenly spaced as much as I can. And then the other thing that might save me a little space is if I make these guys smaller. I'm actually going to delete this construction line for right now. Just select those two section tags and type in scale 1D. And I can use the midpoint, and scale 1D will allow me to scale something in one dimension, as you might expect. I could kind of move those in a little more. Maybe till they're right outside my dashed line. Okay. And then back on my drawing page, you can see we're already kind of out of the way. I double click one more time to move it over. Okay, great. And what I also can do in my layout is I can preview what my line weights will be before I've printed. So up in the top left, I can go right click, go down to where it says print preview. And because we've defined all these properties for our layers in our layers panel, you can see it's showing us what this drawing is going to look like when we print it already. And we can also hit zoom 1 to 1, or type in Z, enter, hit 1 to 1. So that should be pretty close to like what you'll be looking at with a printed out 11 by 17. We can kind of get a sense of whether our line weights are really reading properly or not. So, you can do the same thing in your Rhino viewport, but the problem is that Rhino viewport doesn't know what scale you're looking at your model with, right? So, as we zoom in and out, the thickness of the line isn't changing, right? It's just getting, it's just getting what looks like heavier and what looks like thinner, because we're zooming in and out, changing the scale of the drawing in essence. So on the layout, we can actually see, no matter what a scale of zoom we're at, we can see what the line weight will be when we print it. And we can go in here and fix things that are too light or too heavy, or kind of not reading properly. Okay, so the last thing I should explain is we also want to go ahead and add the information to identify all the drawings in here under the the different sections of the title block. What I want to do is change my current layer to dim or dimension in order to add the text, and then I'll just type in text or use the command text. So I could say under class arc 241, click OK. You can see our text is massive. That doesn't matter. We'll just click somewhere. We can drag it around. And then with the text selected under properties, under the text button, I can change the height to, I don't know, 0.25. Okay. And then I'll just copy each one from here. Okay. So under date, I would put whatever day it is. Under drawn by, I put my name. You'll put your name, obviously. Now you can see this text box, there's two, it's overflowing on my page, so it would get cut off if I printed it like this. Now to fix that, I can press enter, to return, or I can select my text and select this little dot at the outside to define like the limits of my text box. And I can just bring that in to keep it in the box. So under this, you would also put our teacher's name. Make sure you spell it right. Under your TA, okay. Oops. So we can also make this text smaller if we need to. Oops. I could make it like 0.125. It's easier to fit in there. Okay. And then the title is going to actually be the, the title, in this case, of the assignment and of the document. So this is going to be project 2A, shop drawing. And I also would ask you to identify wood frame in this section. And then under sheet number, you just want to go ahead and label, what number this is in the sequence. Okay. And finally, we would actually start to add dimensions and text to kind of explain what these drawings are. And I'm going to go ahead and leave that to the next video. I will sign off.